Hello and welcome back to the channel. In this video, we're going to be learning about why strings are known as immutable in Java. Now, in the last video, we learned about strings, and there we learned that strings are non-primitive data types. Even though you can use them like primitive data types, they're not primitive data types. Strings are quite different. Now, because of this difference, strings are also stored differently compared to primitive data types. The term immutability might not make too much sense now, but by the end of this video, you'll understand what this means and why it's important in programming. Now, the first thing you need to understand is how different data types, primitive and non-primitive, are stored in memory. In Java, the memory is divided into two different types. The orange column is often called the stack memory, and the purple column is called the heap memory. Now, you don't have to know the names, so I didn't really write the names. All you need to know is that there are two types of memory. And now we're going to make some variables and objects, and we're going to see how they're stored in this memory. Now, if you store primitive data types, they're always stored in this orange column. For example, let's say I have a variable called var of the int data type, and I set it to the value 5. The value and the variable is going to be stored in this orange column. It has nothing to do with this right purple column. Now, an object is stored a little differently. Let's say I made a class called superhero and I made an object of the class called obj. The name of the object is going to be stored in this left column, but the actual object is going to be stored in this other column. Now, the first question you might have is that if they're stored separately, then how would I use the methods of this object using this object name obj? To do this, we're going to use what's called pointers. This obj object in this left column is going to be storing a pointer that points to this actual object in the right column. So the name of the object is going to be stored in this left column, but the actual object is going to be stored in this right column, and you're simply using a pointer to point towards this object. Because of these pointers, we often call our classes and objects reference data types, because you're using these pointers in one part of the memory to point towards an object in another part of the memory. Now, if you remember, you should also know that arrays are non-primitive data types. So if I make an array called A of the int data type, and if I give it values like 3, 6, 8, 10, the array is going to be stored in one part of the memory, while the actual values or the actual array is going to be stored in a different part of the memory. This array A is going to be storing a pointer that points towards this different part of the memory. Now let's think about a different scenario. Let's say we make an array called B and we set this array B to A. In your actual program, this is going to look something like this. You notice that I made an array called A which is set to these values 3, 6, 8 and 10, and I made another array called B which is set to A, meaning B is also going to be storing these same values. Now in your memory, when you set B to A, B is simply just going to be storing a pointer that points to the same values that A points to. Both B and A points towards the same array 3, 6, 8 and 10. And this causes some weird things to happen. Let's say we use our array B and we change a value in this array. Let's say we change the first element to 5. You notice that I'm not just changing the first element for B, I'm also changing it for A. So you notice that just by changing one of these arrays, I can change both of my arrays. This might be useful in some cases, but in many cases we don't want this to be the case. B should function separately and A should function separately. If you want to do that, obviously you can set the values separately. Instead of setting B to A, you can set B to a different set of values and A to a different set of values. Now we're going to use our original two arrays, A and B, to show that arrays are indeed mutable. If you change the elements of B, since A and B are pointing towards the same set of values, A would also change. Here you notice that I have an array called A which is set to the values 3, 6, 8 and 10, and I have an array called B which is set to A. Now we're just going to change an element of the array B. Let's just say B of 0 is going to be equal to 5. We're basically changing the first element of the array B to 5. Since A and B are pointing towards the same set of values, this means that the first element for A should also change to 5. To show that this change has actually happened, let's print the value of the first element of A before this change and after the change. So you notice that I added two println statements which is basically printing the first element of A. So over here, you notice that this should print 3 because the first element is 3 and we haven't really changed any of the elements. Once you change the first element using B, since the element should also change for A, when you print A of 0, it should print 5. Let's just run this program and see what happens. So you notice that when I run this program, we get 3 and then we get 5, showing that arrays are indeed mutable. If two arrays points towards the same set of values, changing one array would change the other array as well. In your actual program, that will look something like this. You can see that A is set to these values, 3, 6, 8 and 10, but B is set to a different set of values, 5, 6, 8 and 10. They are storing different sets of values. They are not pointing towards the same set of values. And this is also the reason why arrays are known as mutable data types. When both arrays points towards the same set of values, changing one array would change the other array as well. Now, this should give you some idea about why strings are known as immutable data types. Now, we understood how non-primitive data types and primitive data types are declared and initialized in memory. Now, let's look at how strings are stored in memory. So, let's say we make a string called str1. Remember, the strings are non-primitive data types. So, the name of the string str1 is going to be stored in this left part of the memory, but the actual string that it points to is going to be stored in this right part of the memory. Unlike before, the string is going to be storing a pointer that points towards this actual word or sentence, hello world. Now, if I make a different string called str2, and if I set this to str1, you can notice that like before, str2 and str1 both point towards the same string, hello world. So in your program, this will look something like this. You notice that we have a string called str1, which stores the value hello world, and we have another string called str2, which is just going to be set to str1. Even though str1 and str2 are two different strings, both of them are going to be pointing towards the same string, hello world. And like before, if you don't want both the strings to point towards the same string, you can obviously initialize them separately. Both strings are equal to hello world, but they're initialized separately. In your memory, that would look like this, where str2 and str1 point towards two different strings. Now let's take our original case again, where str2 is set to str1. In other words, both the strings point towards the same word or same sentence, hello world. Now if you remember, arrays were called mutable, because if two arrays points towards the same set of elements, if I change the element using one array, it will also change for the other array. If you notice, strings don't work in the same way. In this case, both our string objects do point towards the same string. Now let's say using str1, I change str1 to hello guys instead. You notice that it doesn't change for both the strings. str2 remains pointing towards the original string, but str1 forms a different string called hello guys. Now what if we change str2 instead of str1? The same thing happens. If I change str2 to something like hello everyone, str2 now points towards a different string, hello everyone, but str1 remains pointing towards the original string. And we'll see if this actually works in a program. So you can see I made a simple program over here where I have a string called str1, which is set to the string hello world, and I have a string called str2, which is set to str1. Basically, both str1 and str2 are pointing towards the same string, hello world. Now we're going to change one of these strings. Let's say we change str1 to hello guys instead. So we're just going to say str1 is equal to hello guys. And now we're going to print our str2. Remember that since strings are immutable, if I change str1, it will not change the string for str2 as well. str2 is now going to keep pointing towards the original string, and str1 is now going to point towards this new string, hello guys. So here, if I print str2, you should still get hello world. And you notice that that is indeed what we get. We get hello world. And this shows that strings are immutable. They don't work the same way as arrays do. And that's it. That's all you need to know about the immutability of strings in Java. Now, this might not seem too important now, but eventually you realize that when you're evaluating many programs, it becomes important to realize that some data types are mutable while some data types are not. Thank you for watching and have a great day.